So today we will recapitulate what we discussed last day. Last day we divided. Last day we divided spectacle lenses into three categories: stock lenses, RX lenses, that is prescription lenses, and customized lenses. Stock lenses were lenses, they were readily available in stock. The power ranges were limited. Mostly they were available in -4 with 2 cylindrical. Anything beyond this range has to be prepared on prescription. Those lenses are called RX lenses. RX lenses are customized to the individual prescription. They take more time and there are more variables. So their quality control is not as strong as stock lenses are. Customized lenses are by and large same as RX lenses, but there are certain additional measurements are taken to minimize the difference between the optical quality or optical performance of the lenses on self and on eyes. For selecting an ideal lens for a given prescription, we discussed that there are two factors that are very, very important: lens material and lens design. As far as lens material is concerned, the important elements are refractive index, which determines the thickness of the lenses, thickness in case of concave lenses and thickness in case of convex lenses. Abbe number determines the peripheral performance of the lenses. Reflectance determines the loss of light because of the surface reflection, and specific gravity is responsible for the weight of the overall lens material. We also discussed about lens design. Various lens designs are can be made for a given prescription. Spherical lenses were discovered earlier, and then there were some limitations of spherical lens design. So aspheric lenses were introduced to minimize the limitations of the spherical lenses and improve the optical performance of those lenses by improving the field of clearer vision through the optics of the lenses. Atorics are nothing but the aspheric, meridional aspheric lenses only. They are sometimes also called advanced aspheric lenses. Then we have sports lenses, which are high curve lenses, specially designed and surfaced to fit in an wrap frames. And then any complicated designs can be made, which may not be able to define in such simple terms. Then, apart from the solution category, we have a separate list of lenses for presbyopic populations. Most common among them are bifocal lenses. There are basically three types of bifocals which are very popular currently: round shape bifocal, universe D shape bifocal, and then we also have an E-style bifocal. E-style bifocals are nowadays gradually vanishing from the market. Progressive lenses are now taking the lead role in presbyopic corrections. Most patients are going for the progressive lenses. Progressive lenses are invisible multifocal lenses. They are not only bifocal, but they are multifocal. You can have vision at various distances through the different portions of the progressive lenses. Regressive lenses are occupational lenses. They are especially meant for the presbyopic populations who are working more on computers. They provide vision for intermediate distance and the near vision distance. There is no zone from where one can see the distance being for distance vision. Then there are surface treatments which are used for improving the lens optical and mechanical performance, optical and mechanical properties of the lenses. Anti-reflection coating is one of the most popular surface treatment that enhances the optical performance of the lenses and also prevents the loss of light because of reflection. Then we have hard coated lenses which are called anti-scratch coating, then anti-static coating, anti-smudge coating, water repellent coating, anti-fog coating. These are basically to minimize the care and maintenance of the lenses of the organic lenses which are ARC coated. Besides the normal lenses, we have specialty lenses also, and there are several varieties of specialty lenses in today's optical industry. But among all them, anti-fatigue is very popular for young population who are working on computers for more than 10 to 12 hours. This keeps their eyes relaxed while working on computer. There are other treatments also which are done on the lenses, either in the form of surface treatment or inside the lens matrix to improve, to create some specialized properties in the lenses. For example, Polaroid lenses are very popular. Their Polaroid films are used to prevent the eyes from the glare and improve the contrast. We have photochromatic lenses. They changes color when they come in contact with the UV light. Then tinted lenses are wonderful creation of ophthalmic industry. Probably of all the tools that ophthalmic industry has been gifted with, apart from the lens itself, it is tinted lenses are perhaps color tints and filter lenses are perhaps the most useful tool. As we know, the eyes are the most important source of sensory information. When things go wrong with the visual system, it can have a profound impact on everything we do and we see. For some people, changing the color of the world produces interesting and surprising results. Choice of color or color preference is deeply rooted in psychology and evolution. Red is often associated with the danger, and so is the combination of yellow and black, as often seen on wasps and venomous snakes. It may not be coincidence that the natural color of fields and fruits and the color of the sky and sea are so calming for our eyes. Color preference can also be affected by the pathological conditions like cataract, macular degeneration, complicated neurological disorders like dyslexia and associated conditions, migraine and epilepsy have been shown to be affected by looking through a color lenses. The objective of this explanation was just to talk about the possibility or look at the possibility of choice of tints based upon the prescription. In my opinion, the choice of tint should never be completely left to the ignorance of the user. However, there are no established or proven tests available as to which tint will be suitable to an individual concerned, though there have been several tests which have been tried for this purpose. But it seems that this area is still virgin for research and there is a huge scope for research. However, till then, we can look at the tints as the wavelengths of light. Probably by looking at the tints as the wavelength of light, we can do really some scientific work in this area. So in my opinion, tinted lenses, sunglass lenses should always be dispensed like a spectacle through a professional opticians, because each color has got specific properties. Tinted lenses are used to prevent the transmission of light, and mirror coated are not only used to prevent the transmission of light, but also they are used to prevent the heating effect produced by the excessive light. Gradient tints are basically used for the cosmetic tints. Last day, we also discussed some simple ways of selecting the ideal lenses for a given prescription. We discussed that myopes are more benefited by the lens material, and we also discussed that hyperopes are more benefited by the lens design. However, the considerations for the presbyopic populations are absolutely different. We also discussed about the spherical lenses. Spherical lenses are more curved, they are thicker, but they limit the field of clear vision. We discussed about the aspheric lenses. Aspheric lenses are flatter and thinner. They improve the field of clear vision. Sports lenses, although they have been designed and made by violating the best form lens form, which is compensated by various methods using spherical, aspherical, cylinder, axis, prism, etc. We saw one example how a simple lens prescription is changed to a complicated numbers. We discussed about a difference between an expensive sunglass lenses and a cheap sunglass lenses. Good sunglass lenses are often ARC treated. They are also mirror coated. Any questions? If anyone wants to ask on the spectacle lenses, then I'm ready to take. Otherwise, we can close this here and go to the new chapter for today.
Sir, what happened?
I am changing the PowerPoint now.
Okay. No issue. Today's PowerPoint. Okay.
Yeah, today's PowerPoint. If anybody wants to ask any questions on that, then I am ready to take that. Mr. Larry?
Yeah, make it a slideshow.
Yeah, this is in the slideshow mode. Can you see that? Mr. Larry, can you see my slide?
Yeah, I can see my your slide. Make it a slideshow.
This is on the slideshow mode only.
Press that key. Yeah, same. Press that key.
Yeah, I pressed. Is it okay now? Is it okay now?
Not it. You have to press this one. Move your cursor.
Yeah.
Near to that 60% and some 68%. Na?
I cannot see that very 60%.
Right bottom. Otherwise, make it as full screen.
Yeah, it's in the full screen.
The right end, there is a key. Na? The right end, there is a symbol. Right end. Right end. Yeah. Press.
Yes, I pressed. Can you see the slide now?
But not slideshow.
Sir, actually near that 106%.
Is it okay now?
1 minute, sir.
Yeah, now okay.
Now okay?
Yes, sir. Yes, sir. Yeah.
Slide.
Now it's slideshow.
Maximize the screen.
No, it is okay, sir. You can continue, sir. No problem. Please continue.
Okay. Okay, today we are going to talk about spectacle frames. Again, most of the materials have been taken from my book, Dispensing Optics. Actually, I am unable to see the full slide now.
Sir, actually, you have to reduce that zoom from 106% to 76, sir. Yeah,
I'll do that.
just reduce it, then you will be able to see the full screen. I think, yeah, if you reduce it still further, you will be able to see. Now it's in 87, reduce it to 73 or 76. Yes, sir. Now are you able to see, sir?
Yeah, now I'm able to see it.
Okay, yes.
So is it on the slideshow, no?
Yeah, it's on the slideshow only, sir. You can continue, sir.
Okay. Spectacle frames are an assembly of two distinct parts, the front and the sides. These spectacle frames are used for fitting spectacle lenses so that they can be used to serve the purpose of eyewear, either as a vision correction gadget tool or as an accessory. Basically, there are two types of spectacle frames available in the industry, which we call them a dress wear spectacle frames and wrap spectacle frames. You can see in this figure, the top figure shows the dress wear spectacle frames, and the bottom figure shows the wrap spectacle frames. Dress wear spectacle frames are mostly used for the spectacle lenses, and wrap wear spectacle frames are mostly used for the sports sunglasses. The basic difference between the two types is in the way they have been constructed. Sports frames are constructed to have a average pentascopic angle of 16 to 20 degree, whereas dress wear spectacle frames are constructed to have an average pentascopic tilt of 5 to 8 degree. When they come out of the factory, they have 5 to 8 degrees of pentascopic tilt. Dress wear spectacle frames are constructed to have a panoramic angle of panoramic angle of 5 to 8 degree. I made a mistake, I'm sorry. And pentascopic angle 9 to 12 degree for wrap wears, and pentascopic angle 3 to 5 degree for dress wear frames. And average vertex fitting distance for a sports frame is 11 millimeter and dress wear frames is 14 millimeter, which means sports frames are fitted more closer to the eyes than the dress wear frames. And for face front bow, which is panoramic angle, is much more in wrap frames than dress wear frames. So is the case with pentascopic angle. Because of these variations, we need to change the lens, and we need to make the compensations so that they can work same as a dress wear spectacle frames. Wrap sports frames have a larger A measurement than the B measurement, which means horizontally they are wider than the vertical aperture of the lenses. As far as materials are concerned, basically there are two types of materials used to manufacture the frames: metal frames, metal bodies, and the plastic bodies. Among the metal, we have precious metal frames made of metal alloys and other metals. And in plastic, we have two categories of plastic material. One of them is thermoplastic material, another is thermosetting. Different varieties of plastics are used to manufacture spectacle frames: celluloid nitrate, celluloid acetate, celluloid propionate, carbon fiber, optil, nylon. There are different manufacturing technology used for each of this. Celluloid nitrates are nowadays obsolete. They are out of the industry. Most sheet frames are made of celluloid acetate material. Celluloid acetate is a seed from which the plastic frames are made, whereas celluloid propionate and nylons are used to manufacture the frames using the molding technology. Optil fibers are no more available in the industry. In metals, we have gold, silver, and white gold in precious metal categories, and we have roll gold, nickel alloys, monoalloys in metal alloys category. Besides metal alloys and precious, other metals are also used to manufacture optical frames. Titanium, aluminum, stainless steels are very common. Titanium is supposed to be the hardest material and the most ideal material for the spectacle frames. Different shapes are available for spectacle lens frames. Round shapes, narrow rectangular shape, as you can see at the middle picture on the left hand side. Then at the bottom, you can see the pento shape. Then we have an aviator shape. We have the square shape also. Now you need to understand that each shape is not suitable for every kind of prescription. For example, this narrow shape is usually not recommended for bifocal lenses, and this aviator shapes are not usually recommended for the presbyopic lenses. In round shape frame or this pento shape frame, good optician will never like to fit high cylindrical lens prescription, because the lens will have a tendency to rotate within the lens frame, and which will change the axis on the eyes. So round shapes and the pento shapes are usually not recommended for high astigmatic prescriptions. Square shapes are most ideal for all kinds of lens prescription. As far as metal manufacturing processes are concerned, metal frames production is a very precious process that may require more than 150 operations, including more than 2 dozens of inspection process. They are manufactured by engineering process such as rolling, pressing, drawing, milling, slotting, shaping, barreling, drilling, coloring, and stamping. These are just the name of few of the processes that are applied while manufacturing metal frames. For plastic frames manufacturing, broadly two kinds of manufacturing processes are applied: milling process and injection molding process. In the milling process, a computer controlled machine carves the frame from the colored plastic sheets. This process produces rims, temples, and bridges that are then assembled, finished, and packaged. Materials used for milling process are celluloid nitrate sheets and celluloid acetate sheets. For injection molding process, plastic resins, or in the form of liquid or in the form of granules, are injected into the molds. The plastic parts are then assembled, coated, finished, and packaged. Common material used for injection molding process is celluloid proponate, acrylamide, Trivex, TR55, which is a brand name of TX5, nylons, polyamide, and epoxy resin optil, which is no more available. Some of the common parts of the spectacle frames you can see in this picture. This is the rim, eye wire we call it. This is side band, and this B is the facial width, distance between the two sides. This is a very important distance to adjust with the temple width of the user. Then the C is a bridge which works as a bridge between the right lens and the left lens. Then these are nose pads which are hanged in the metal frame with the help of these knobs. These knobs are the smallest part in an spectacle frames. Then this is joints. Here you can see the spring. Spring means they make the temples stretchable. There are two types of pads available. Here you can see the flexible pads, which can be adjusted to the shape of the nose of the user. And here you can see the fixed pad, which cannot be adjusted to the wearer's nose. They are fixed. Different types of frames are available in the industry. We have full rim frame, where we have the rim all around the lenses. We have supra frames, where we have the metal rims or plastic rims only at the top portion of the lenses, and at the bottom, the lenses are held with the help of nylon thread. Rimless, there is no rim. The lenses are either hanged with the help of screws or with some sort of plastic structures. New mount frames are no more available. Bell grip frames are no more available. The double bridge shapes are very, very common. They are still available mostly in the aviator shape. And then we have an occupational spectacle in the form of half-eye frames also, which are commonly used for reading purpose. The increasing complexities of lifestyle and ever-changing aspiration values have changed the way people look at their eyewear or spectacle frames. Somebody is drawing, I think. Today in modern society, eyewear is no more a tool to hold the lenses only. They are also the fashion accessories. A spectacle frame has to look good and also provide maximum wearing comfort. People like to express themselves by their eyewear. You can blend in or stand out in a crowd. You can have an intellectual look or something very modern and stylish. A rightly selected frame can actually enhance your features or compensate for not so good facial features to make you look good. For a dispensing optician, frame selection entails much more than just helping a person try on frames. In fact, this is the most important function of the dispensing optician. The secret of success in optical dispensing lies in the art of selecting the right frame for a patient. People often forget that having eyes examined by an expert professional is just one part of the correction. If the spectacle frames are not correctly selected and fitted, then even the best refraction will not provide the desired results. It implies that a dispensing optician needs to go beyond the paradigm of techniques and science of dispensing to understand the basic conceptions of shapes, colors, and styles. Based upon this, we can devise the laws of selecting the ideal frame for a given spectacle. The law number 1, frame matches to the lens prescription of the wearer to provide the desired optical function. This is based on the conception that not all frame styles are equally appropriate for each lens prescription. Frames as the means for carrying the lenses is critically important in dispensing to transfer the clinical findings into reality. The wearer needs to understand that frames vary in their shape, size, and style, and an appropriate selection can make things significantly compromised in terms of visual performance through the lenses. The straightforward implications is that there is a potential for improvement with an appropriate selection of frame. Law number 2, the frame looks good on the wearer face. Looking good is a very important criteria for the thing to be used. The hypothesis is that anything that looks good does not look good is not used. It is therefore important that the frame does not make the wearer feel out of the date or conspicuous. Law number 3, the frame provides the maximum wearing comfort. This law is based on the assumption that a frame that fits well also provides the maximum wearing comfort. Disadvantages like frame slipping and tight fit should be minimized. If the spectacle frames are uncomfortable, the wearer will be aware of it and they will be distracted by using them. Law number 4, the frame style matches to the lifestyle of the wearer. This is based upon the conception that one style does not fit to all occasions or does not serve all purpose. Most people would not like to adjust to one style or one look. Understanding lifestyle is the key to cater the specific needs, which includes occupations, recreations, and other concerns like wearers' likes and dislikes in general. Now, if the spectacle frames have been selected following these laws of spectacle frame selection, the frame selected will be comfortable, they will look good, and they will be used for longer time to achieve the desired objective of the dispensing. So these are the law of selecting the frame selections. If we follow, we can have a good dispensing. Now, while selecting the spectacle frames, you need to also consider the important parts of the spectacle frame that leads to the ideal fitting on the user's face. Most important among them are the frame size, frame shape, bridge of the frame, frame color, frame design, ergonomics. We'll talk about all these factors separately. Now, as far as the frame size is concerned, it has to match with the temple width of the user. Usually, larger size of the frames are never recommended for the higher prescription, especially in the minus prescription, because they enhances the thickness of the edge thickness of the lenses and also affect the visual performance through the periphery of the lenses. Now, frame shape is another criteria for selecting the ideal frame for a given prescription. As we just discussed in the previous slide, round shape frames are usually not preferred for high astigmatic corrections because sometimes the axis of the lens rotates within the lens rims. So then the optical performance of the spectacle is compromised. Aviator shapes are not good for the presbyopic lens types. Square shape is absolutely perfect for most lens prescriptions. Narrow rectangular shapes are always useful for the single vision lens prescription, not for the presbyopic lens prescription. Bridge of the frame determines the ideal fitting also as well as the comfort. If the bridge is not appropriately fitted, it will not be used comfortably and the patients will always have difficulties using the frames. Now, bridge fitting is important while selecting the plastic frames, not in the metal frames, because in metal frames the nose pads are flexible. We can adjust the fitting of the metal frame bridge by moving those two nose pads in different positions, but this is not possible in case of plastic frames. Frame color, usually it is said that the color of the frame selected should be contrasting to the facial color. However, the personal perception rules the world for this, but the general rule is that a fair complexion people should be given darker color of frame and the dark complexion people should be given either the medium dark or the lighter version of the shades. As far as this frame design ergonomics is concerned, this is the most important aspect of frame fitting, and we will discuss this in elaborate. First of all, let me tell you, ergonomics is a word which is very commonly used in the furniture industry, and it relates to efficiency and the comfort. Same is the case in this for optical frames also. When I talk about the frame design ergonomics, what I mean to say how the frames are constructed to for the purpose of using on the individual space. Frames are actually engineered to maintain a balanced and secure fit. They are crafted to ensure comfortable contact at the bridge of the nose and behind the ears, and to provide an innovative new look to the overall design of the frames. Now, in order to do that, there are several elements of frame parts which are being constructed and designed, but two among them are the most important. Number one is bridge and number two is the temple. Now, there are different positions of the bridge and there are different positions of the temple. We'll discuss about it. You can see in the picture, there are different positions of the joining of the temples with the frame front has been given. And on the right hand side picture, you can see the extreme right frame, the sides are joined with the front at the top, and on the extreme, in the right same picture, on the extreme left frame, you can see the frame side has been joined with the frame front at the mid portion. We'll talk about all those. Now these sides, which are the temples, are attached to the extension of the frame front, which is called lux. Temple, when it is joined with the spectacle frame, interject an artificial dividing line that divides the frame front into two halves. The lower the line, shorter it appears, and higher the line, longer the face appears when viewed from the side. When the sides are joined with the frame, at the lower portion of the front, the face will appear shorter, and when the sides are joined at the top of the frame front, the face will appear longer when you view from the sides. If the temples are attached higher on the frames, there is more facial area below the line and the face appears little longer. If the temples are attached lower on the frame, there is less distance from this line to the bottom of the chin and therefore the face appears shorter. Joining जो साइड की फ्रेम फ्रंट से होती है, ये फेस के वर्टिकल शेप को डिटरमाइन करती है पहनने के बाद में. यदि ये साइड को फ्रेम फ्रंट से नीचे की तरफ ज्वाइन किया जाता है तो फेस जो है यदि आप साइड से देखोगे तो छोटा दिखाई पड़ेगा, और यदि ये साइड टॉप पे ज्वाइन किया जाता है फ्रेम फ्रंट के तो आप यदि साइड से देखोगे तो यूजर का फेस टॉलर दिखाई पड़ेगा, लंबा दिखाई पड़ेगा. So this is how this ergonomics affects the selection of the frame. In general, temples that are attached to the frame front a little above the datum line ensures a balanced look. Datum line means the line, it's an artificial line, it's an imaginary line that passes through the center of the lens aperture in its vertical measurement. So any frame where the temples are attached with the frame front little above the datum line, they ensure a balanced look because the division is almost 60-40. Now this frame ergonomic has a lot of impact on the wear dispensing. The position of the joints in the vertical plane along the frame front, the fix of the frame as it affects the impact on the pentascopic angle. Top joints frame usually show inadequate pentascopic tilt. जब फ्रेम का साइड्स इसके फ्रंट से टॉप पे ज्वाइन होता है तो यदि आप उसको साइड से देखोगे, पेशेंट के साइड से देखोगे तो आपको लगेगा कि इसमें पेंटास्कोपिक टिल्ट कम है, मतलब there will be lot of gap between the cheek and the lower rim of the frame. And this is an important criteria for frame selection. Center joint frame in this respect is the most ideal as it ensures a balanced pentascopic tilt on the wearer face. Although from the factory, when the frames have come out, they might have a standard pentascopic tilt of 6 to 8 degrees, as I told you in the previous slides. But when you put on the face, it might look little changed on different wearer. Low joint frames causes greater fitting problem than the high joint frames because their center of gravity may result in somewhat precarious balance. Moreover, low joints affect the inferior temporal field of the view, while high joints normally do not. A center joint temple frame may affect the temporal field of view if the sides are very thick. So patient might complain that I cannot look by moving my eyes on the sideways. Temple thickness also affects the look of the facial length. Broad temples reduce the apparent facial length, whereas thick temples increases the apparent facial length of the wearer. Bridge is second important criteria for designing the frame. The position of the bridge, thickness of the bridge, width and the type of the bridge are critical. Basically, there are two types of bridge available in the industry. We have a shadow bridge and we have a normal bridge, which is called keyhole bridge. You can see in this picture, the top picture A shows the saddle bridge, and the picture B shows the keyhole bridge. Now in keyhole bridge, the contact is at these 2 points only, whereas in saddle bridge, the contact is all across the nose area, at the top of the nose, at the nasal flanks also. Top bridge is usually designed with the top joint frames. They expose much of the nose, so the nose looks lengthened. Whereas bottom bridge, as you can see in the picture A, it shortens the length of the exposed nose. Shape of the frame, as we discussed in the previous slide, square, rectangular, aviator shapes are the common shapes for men, whereas oval, rectangular, and pento shapes are very common in females. The general rule is that the shape should cover the eye adequately, and it should be ideally from all around, so that the eyes are right at the center of the eye aperture and near the center of the lens opening of the frame. Facial shapes of the wear is important criteria for the frame selection. There are different types of shapes, facial shapes we'll discuss now. Oval face, as you can see in this picture, is the most ideal shape for spectacle frame selection. Most frame shapes suits to this face. Now, while selecting the ideal frame shape for oval face, we should try and match the shape of the frame with the widest part of the face, and you can see the widest part in this case is here on the above the spectacle lid. So the frame selection has been done to match the width of the widest part of the face. In such cases, almost all shapes suits. Round shapes, rectangular shapes are very ideal for round shape face. No other shapes fits this round shape frame, because ideally you need to select a frame where after using the frame, the face should look like an oval. So if you dispense this round shape patient, round face patient with a rectangular frames, it will make the face apparently oval. Square shape face frame should make the face look longer. The frame should, ideal selection of the frame should make it longer towards or nearer to the oval. Select the frame with weight on the top of the frame so that the face is lengthened. Key mount kind of frame, rim master kind of frame, or retro style frame shoots very nicely on these faces. Oval frame shapes with the top center joint will also suit these cases. If the frame has the decorations or some dramatic design at the upper rim or the temporal corner, that will also enhance the look of the square face. Most difficult face to select the right frame. This is a taper shape, top cat's eye shape or aviator shape frame may suit in these cases. But it's really difficult to select the right frame for such faces. Diamond face frame should be widened. Frame should widen the forehead and jaw and minimize the appearance of the cheekbones. As you can see here, the cheekbones are widened. You need to select a frame which minimize the apparent width of these cheekbones. Rimless frames, square frames, or straight top frames may work in such cases. So this is about selecting the ideal frame based upon the ideal face and the lens prescription. Now we'll talk about frame measurements and frame fitting. Now, in order to understand the fitting of the frame on the user's face, we need to hypothetically understand a fitting triangle. It is an imaginary drawing when somebody is wearing the spectacle, and if you have a look on that on the user from the top of his head, you will notice that ideal spectacle frame should fit in such a manner that it makes contact only at 3 points on the wearer's face. One at the nose and two on the two ears. So if you draw a line from the nose to the two temples to the two ears, you will make a triangle. So the concept is called the fitting triangle. These are the 3 points only where the frame should ideally touch on the patient's face. Now, while checking the fitting of the spectacle frame on the wearer, there are certain parameters which you must make sure that they are properly fitted. First is side length or side bend. Then we have a frontal bow or face form wrap, or we also call it a panoramic angle. Then temple width or facial width. Then pentoscopic angle. Pentoscopic angle is a vertical. It determines the vertical fitting of the spectacle frame on the wearer face, and this is a very important fitting for not only for bifocal lenses but also for single vision lenses. Then in metal frames, you also need to adjust nose pads. Last but not the least, you also need to make sure that the frame is aligned properly. There is a process of checking the fitting on the wearer face. The sequential process. It follows first, in an ideal scenario, you must see the temple width or facial width. Now, temple width means distance between the two sides. It must conform to the facial width of the user. Then you should check the frontal bow or the apical curve or panoramic angle. All these three means the same thing. So first you are checking the temple width and then you are checking the frontal bow. Now with these two fitting checked, you complete the horizontal fitting of the spectacle frame on the wearer's face. Then you come to the pentoscopic angle, which determines the vertical positioning of the spectacle frame on the wearer's face. Then you go behind the user's ears and see whether the side bend has been properly done. Side bend has to follow the curves of the ears of the user. Then you have to check the nose pads. We'll talk about it in our later slides. And finally, you need to check the standard alignment for the frame. On a tabletop, there is a 4-point contact method of ascertaining the standard alignment. This is how you should check the fitting on the wearer's face. However, while you understand this fitting assessment of fitting process, you must understand the human skull. There are a number of variations of human face that you can see, but there is one very unique and common aspect that is being observed in most people. That is, the anterior part of the head is a vest. Here you can see is the anterior part of the head is a vest. The plane of the face normally represents this plane of the face normally represents the narrowest, and as you go away from this towards the back of the head, it starts becoming wider, and the widest area is around the ears. Then it is followed by another base step behind your head. This is the unique shape of human face you will see in most cases. Now, whenever you fit anything which has a front and a side on human face, there are two important criteria which must be considered while determining the ideal fitting. One of them is horizontal fitting and the another is the vertical fitting, which is vertical angle of the sides. Horizontal angle relates to the angle of laid back, or we call it a temple width and frontal bow. And vertical angle is determined by the pentascopic tilt, as we discussed just now. You can see this in this angle of lead back here. It is the angle between the side and the front. You can see it's a 90-degree angle has been made here. Now in wider face, this angle, wider face selected with a smaller frame size, this angle may go up. Pentascopic tilt is the angle between the temple of the frame near the joints and the superior rim of the frame front. It determines the vertical positioning of the spectacle frame on the mirror face. Here you can see on the right picture, in the picture A, it shows the positive pentascopic angle. In picture B, it shows the negative pentascopic angle. Now this negative pentascopic angle will affect adversely the near vision through the spectacle lenses. The angle of the lead back is more important, as a smaller lead back angle means the frame front will propel forward. ये जो आप देख रहे हैं, angle of this lead back here, this angle, the angle, horizontal angle between the front of the frame and the size, it determines the temple width of the frame. Okay, ये bearer के face के width से conform होना चाहिए, match करना चाहिए. यदि ये फ्रेम bearer के face के width से छोटा है, narrow है, तो frame will propel out. It will not stay on the face. It will keep sliding down on the nose. और यदि ये बहुत बड़ा है, gap is too much. If there is a too much of gap between the side and the temporal bone of the wearer, it means the frame is loose. It will not stay on the user's nose and it will keep falling. So this is a very important criteria you need to understand. Now, apart from this temple width, you also need to understand that sometimes you also need to curve these temples. Now this is very important, especially when the wearer face is round, because this temple should not touch anywhere between the frame front and before the ears. So there should be a little gap. It should only create a tangential relation with the temporal bone. So in order to create the tangential relationship, you need to curve the sides from the sides. You need to curve the sides. Nose pad fitting is very important because it determines the stability of the frame and the comfort of the frame on the user's face. Three important criteria are very important to determine the ideal nose fitting: frontal angle or spread angle, splay angle, and the vertical angle. On the picture, on the extreme right of you can see the frontal angle. The frontal angle is the distance between the two nose pads. The nasal flank, the shape of the nasal flank determines the splay angle of the nose pads. Chinese face, where there is no nose, the splay angle will be larger, and the European faces, where we have a very sharp feature nose, the splay angle will be smaller. Vertical angles, you can see here, the top portion of the nose pad should be little away from the front rim, and the bottom portion of the nose pad should be little closer to the frame front. The frontal angle determines the distance between the two noses. It covers the entire width of the nose. The splay angle is the angle of the nose pad that should complement the angle of the nose at the point of contact. Here you can see this is a splay angle ideally designed for a Chinese nose, and this is a splay angle. It is fitted for an European nose. The vertical angle, as I told you, the gap between the nose pads at the top should be larger than the gap between the nose pads and the frame front from the bottom. It denotes the angle of the nose pads as it is positioned. In an ideal scenario, as I told you, bottom should be closer to the rim. Now let us summarize what we discussed. The size of the spectacle frame for individual should be selected in a scale with the size of the facial width. यूजर का जो फेशियल विड्थ है उसके अनुसार ही फ्रेम का साइज सिलेक्शन किया जाता है. For a broader face, we need to select a larger frame. For a smaller face, we need to select a smaller size. Now, there is a myth prevailing in the industry. I have seen that the most practitioners suggest a smaller size of frame for the small kids. In case of small kids, in my opinion, ideally a one size larger should be selected, because for kids, temple width is always and eyes are always very close, but temple width is always very wide. So if you select a very small size frame for them, it will not stay on the nose properly. It will keep slipping down on the nose. So then vertex distance will change, and change in vertex distance means change in the effective power, which will affect the refractive correction of the kids. So for kids, besides that, kids are growing, their facial size changes, increases, their facial shape changes with the time, and it changes very fast. So in an ideal scenario, we should select one size larger than they require. There is one more reason behind this. In case of kids, usually they try to look through the upper portion of the lenses. Now, if the frame is very small selected, then they will try and look through the top, above the top rim of the frame. So they will not be looking through the optical spectacle lenses. So that means correction of vision will not have any importance for them. So in an ideal scenario, one size larger should be selected for kids, and ideally round shape or oval shape should be preferred compared to the narrow rectangular shapes, so that the kid always look through the center of the lenses. The shape of the frame for individual should be in contrast with the facial shape, as we discussed. The correct selection of the bridge is very important. We discussed about, because it determines the comfort and also stability of the frame on the user's face. Oval shaped face is the most ideal facial shape, in which case you can fit most shapes of the frame. Rectangular shaped frames are mostly ideal for round frames. A top bridge will expose the nose to appear it a little longer than what actually it is. A frame that fits well also looks good and can be used for longer period of time. That's all about the spectacle frames. So in case you have any questions, we can take, or otherwise we can go to our next lecture for today. Any question, please? You can write your questions on the chat box also. My chat box is open.
Hello.
Yeah. We are through with the lecture for this lecture.
Hello.
Yeah. I can hear you.
आवाज आ रही है? Okay. सर लेंस के ग्लासेस के बारे में पूछना था.
हाँ जी.
ब्लूरे ग्लासेस का क्या?
फिर से बोलिए.
ब्लूरे लेंसेस.
Flure?
हाँ.
You are talking about blue cut lenses?
Yes.
Okay. Last day we discussed about blue cut lenses. Blue cut lenses are lenses which are used to prevent the transmission of high energy visible blue, because which are harmful for the eyes. Is that clear?
पर वो इतना अफेक्ट करता है क्या कि 80-90% वो रिफ्लेक्ट नहीं होता जो ग्लासेस का?
There are two ways of creating the blue cut lenses. One, it is created by the surface treatment. Another, it is created by the lens matrix itself. So if it is created by the surface treatment, then it also prevents the reflection of the light. Is that clear?
हिंदी में बात करो।
हाँ जी, दो तरीके से ब्लू कट लेंस बनता है, एक सरफेस ट्रीटमेंट से बनता है और एक लेंस मटेरियल के साथ भी बनता है। यदि सरफेस ट्रीटमेंट से ये ब्लू कट लेंस बनाया गया है तो ये रिफ्लेक्शन भी प्रिवेंट करता है, और यदि मटेरियल से बनाया गया है तो ये रिफ्लेक्शन प्रिवेंट नहीं करते। आइडियली एक्चुअली रियल वर्ल्ड में क्या होता है, सॉरी, दोनों चीज यूज की जाती है। जो अच्छे ब्लू कट लेंस होते हैं ना, उसमें ब्लू प्रोटेक्शन मटेरियल भी यूज किया जाता है, ब्लू लाइट प्रोटेक्शन मटेरियल भी यूज किया जाता है, और एंटी रिफ्लेक्शन कोटिंग भी की जाती है, इसलिए ये रिफ्लेक्शन भी प्रिवेंट करता है।
पर ब्लू कट में और ARC में क्या डिफरेंस रहता है क्या?
Yeah, good question. It's only the selective transmission of light. That's the only difference. This is one difference. One minute, let me complete, please.
Okay.
One is selective transmission of light. Secondly, blue cut lenses, the base material is a tinted material, a bit tinted material with yellow tinge. You will see that blue cut lenses are little yellowish in tint, whereas the normal lenses are not yellowish in tint.
पर वही थोड़ा क्लियरिटी ब्लू कट लेंसेस में 5-10% थोड़ा सा डाउन होता है वो येलो।
Yeah, because yellow tint होता है ना, tint होने से ही विजन का टेल होगा।
हाँ, पर जो वही मेरा सवाल था कि जो अपन जो लेजर का जो इस्तेमाल करते हैं कस्टमर को बताने के लिए।
हाँ जी, मेरे को सुनाई नहीं पड़ रहा, आपकी आवाज कट रही है।
हेलो, आ रही है अभी?
कट के आ रही है।
हेलो, अभी आ रही है?
हाँ जी, I can hear you. Yeah.
ओके, वही कि हम जो बताते हैं कि ARC से ब्लू जो लेंसेस है, ब्लू रेज है, वो पास हो जाते हैं, और ब्लू कट लेंसेस से लगभग 90% रिफ्लेक्शन मिलता है। तो ARC और ब्लू कट पे इतना 90% डिफरेंस अफेक्ट करता है क्या कस्टमर?
आप ये समझने की चेष्टा करिए, ARC जो अच्छे ARCs होते हैं ना, वो यूनिफॉर्म ट्रांसमिशन ऑफ लाइट इंश्योर करते हैं अक्रॉस द डिफरेंट वेवलेंथ। तो जो लेंस के जो ऊपर में जो रिफ्लेक्टिव टिंट होता है ना, वो ग्रीनिश पर्पल की तरह होता है।
बराबर।
ओके, तो मोस्ट ऑफ द गुड क्वालिटी ARC आर हैविंग अ रिफ्लेक्शन टिंट ऑफ ग्रीनिश पर्पल। और आप जब भी ब्लू कट लेंसेज देखोगे ना, तो ये आपको लगेगा बहुत सारा, देखिए ब्लू टिंट उस पर दिखेगा, ब्लू रिफ्लेक्शन टिंट के दिखेंगे।
क्योंकि बहुत सारे डॉक्टरों का भी कुछ अभी डॉक्टर से मैंने बात की ना, तो बोलते कि ब्लू कट का इतना इस्तेमाल नहीं होता, वो लेंस कार्ड ने बनाया है मार्केटिंग के लिए।
नहीं, ऐसा नहीं है, इसने लेंस कार्ड ने नहीं बनाया ब्लू कट लेंसेज। लेंस कार्ड मार्केटिंग करता है, इसलिए हमें पता है। लेंस कार्ड नहीं बनाया। ब्लू कट लेंसेज इज अ साइंटिफिक इन्वेंशन, डोंट वरी अबाउट इट। लॉट ऑफ गुड कंपनीज आर डेवलपिंग दिस वन, दे आर वर्किंग बिहाइंड इट। SLR is working behind it.
हाँ, अभी SLR का तो आ ही गया है,
people I have read on this.
पर मतलब अफेक्ट करता है 90%।
Yeah, they are very good. Even personally also I have used and I have personally compared when I am using blue cut lenses while working on laptop, तो थोड़ा सा मेरे को रिलैक्सेशन फील होता है। एक्चुअली क्या होता है ना, मैं आपको बहुत क्लियरली बताता हूँ, इन सब का इफेक्ट आप यदि इंस्टेंटली देखने चाहोगे तो आपको नहीं पता चलेगा। ये ग्रेजुअली आंख पे असर करता है और लॉन्ग टर्म इसका इफेक्ट होता है आंख पे। मैं एक सिंपल सा आपको एग्जांपल बताता हूँ। एक ऑक्यूलर डिजीज है मैकुलर डिजनरेशन। इसका जो सबसे इनिशियल जो सिम्टम्स जो दिखाई पड़ता है वो उस तरीके से दिखता है कि आप कभी सिनेमा हॉल से जब अंदर जाएंगे और बाहर निकलेंगे उसके बाद, तो आपको लाइट के साथ में अडेप्ट करने में समय लगेगा। यदि ये समय अबनॉर्मली ज्यादा है तो मतलब as you will age, it is possible कि उसकी आंख में मैकुलर डिजनरेशन हो सकता है। तो ये एक दिन का नहीं है, ये सालों चीजें चलती है, उसके बाद में जाकर इम्पैक्ट आता है। So these are basically a preventive therapy. They are not corrective therapy. And in India, we don't believe in preventive therapy. Am I correct? Am I clear now?
Yes. Thank you.
Okay. Any other question?
Hello, this is Dr. Shukul. I'm calling from Lucknow.
Good evening.
Hello, am I audible?
Yeah, you are audible.
Yeah, I just wanted to ask something because you were talking about Blu-ray glasses and all those things. What I have known in the literature and everything, most of them, it is still a controversial issue. Actually, it is not affecting the eyes. It is more so causing a change. It is affecting the pineal gland, and the people who are using laptops at night, their diurnal cycle is getting affected. So it is it is beneficial for them. But as such, there is no conclusive evidence that the blue light is causing any damage to the retina, or it is the ultraviolet rays that are causing the damage actually.
No,
So
no,
the
no.
science-
I have not read, sir, anywhere that blue rays are causing the adverse effect on the retina. I have also not read anywhere. But the idea is, try and understand like this. Blue rays are the shorter wavelength of the light, and they are the neighbor of UV rays. They carry a lot of energy with them. They fall before retina. So they create a clouding effect. They reduce the contrast. And they create a very effect whereby you see a little poorer vision. You have a little poorer vision when you have the more blue light entering into the eyes. And then in course of time, since they carry a lot of energy with them, there is a effect. So this is the effect you cannot see immediately. It's been
it is there. It is there.
researchers are
It is there.
telling that long-term effects are adverse on the retina. That's the only thing.
No, it has not been proved yet. It
Okay.
is just a theory. It is just a hypothesis, and it has not been proved. There
All
are
right.
both
So
controversial
I
things.
haven't read any article where it has been proved, whether it has been proved or it has not been proved.
No, there are.
I have some pictures with me.
No,
Some
there
pictures
are.
with me.
Look, if you hear it from ophthalmologist, it would be a different thing.
Basically, these are preventive therapy. And preventive therapy are basically based upon your own beliefs, sir. Any other question? G. Pramila Devi, are you asking any question? Or should I change? Go to the new lecture?
Yes, sir.
All right.
In chat box, 2 questions answered, na?
Okay. More of a marketing gimmick than actually preventing any real damage. I have no answer to that because I don't have any facilities to make research do the studies on this. I am actually in the optical industry where we are so much occupied in day-to-day work that we don't get time to do any sort of research, and nor I have so much of facilities available for research. So I can't argue on this with you. Yes, manufacturers are telling us that they prevent transmission of blue light, which are harmful, and blue lights are divided into 2 categories: good blue light and bad blue light. Good blue light must be transferred to the eye because otherwise sleep cycle will be disturbed. and bad blue light should be prevented from transmission because they might lead to harmful effect on the eyes. So this is the principle which most of the lens manufacturers like Zeiss, Essilor or other manufacturers are telling us. So whether we have a scientific research or not, I have no access to that.
Yes, sir.
Yeah, I'm trying to open my new slide.
Okay. Sorry.
Is this visible, Mr. Hari?
Yes, sir.
The new slide is visible with dispensing measurements.
Yeah, slide is visible. Make it as slideshow.
This is on the slideshow mode only. Okay.
Your screen also in maximize, na? Not in minimize.
Yeah, it's maximized. And it is on 68%.
Okay, okay.
Can I start now?
Yeah, proceed.
Okay. Now, we talked about the spectacle lenses. We also talked about the spectacle frames. Now, we need to talk about the dispensing measurements so that we understand how to fit the spectacle lenses into the spectacle frame to achieve the objectives of the dispensing. For the sake of convenience, I have divided this section of lecture into two parts. Section 1 will be talking about the dispensing measurements, and section 2 will be talking about the dispensing challenges. Now, there are several dispensing measurements that we need to take while dispensing the spectacle lenses, but we will restrict our discussion today for the sake of this course to these three types of different measurements. One is pupillary distance measurement, sorry, and then multifocal segment height measurement, and then we will also talk about the measurements for the customized lenses. Now, we will stress more on pupillary distance measurement and multifocal segment height measurements, but we will just have a passerby idea on the customized lens measurements. Now, before we start talking about the measurement procedure, let us understand what exactly is pupillary distance. Now, the anatomical interpupillary distance is the distance from the center of one pupil to the center of the other pupil, measured in millimeters. You can see in this picture, the distance between the center of the two pupils is termed or is called as an anatomical interpupillary distance. Now, this distance can be measured one this way from the center of one pupil to the center of another pupil, and it can also be measured from outer limbus of one eye to the inner limbus of the other eye. In both the cases, we will have similar measurements. Now there are two types of IPDs we need to measure. These two IPDs serve two different purposes. One is a distance PD, another is near PD. Distance PD is the distance between the pupil when the person is looking at something which is far away. When a person is looking at a far away position, their eyes goes further from each other, they diverge. Now near PD is the distance between the pupils when the person is looking at something close to him at a 40 centimeter distance. When a person looks at a closer distance or at a 40 centimeter distance, his eyes turn in and goes down. For this near PD is always, for this reason, the near PD is always little less than the distance PD. Usually the number is 3 to 5 millimeter. Ideally, distance PD is measured monocularly and the near PD is measured binocularly. You can see in this picture, the vertical green line below the number 0, from there to a dotted green line below the number 30. If the distance is measured from the center of the pupil to the center of the nose, we call it a monocular PD. And if the distance has been measured from the center of the right pupil to the center of the left pupil, we call it a binocular PD measurement. Now, distance PD, any PD measurement for the distance vision glasses should always be measured monocularly, and PD measurement for the near vision glasses should always be measured binocularly. The reasons are fairly simple, because when we look at the distance, our eyes goes out. Hence, monocular PD helps us keep the patient's line of sight equally centered for better visual performance through the lenses. Now, why this pupil IPD measurement is so very important? IPD measurement must be aligned with the optical center of the lenses on the visual axis of each eye while dispensing. Now, if there is a misalignment, there are a lot of difficulties that the patient may feel. Distance PD is needed for single vision distance lenses. Near PD is needed for single vision reading lenses, and for bifocal or multifocal lenses, both distance and near PDs are important. Now, when the IPD is not aligned with the optical center of the lenses, patient's visual axis does not pass through the optical axis of an ophthalmic lenses on the eyes. And when it is not passing through the optical axis of the ophthalmic lenses, it induces prismatic effect. The amount of prismatic effect, amount of induced prism. Yeah.
Sir, excuse sir.
Yeah.
The slides are not moving.
The slides are moving. Is it okay?
Moving.
I am moving the slides. Is it moving?
For others, not moving.
Let me try once again.
For me also not moving.
So should I go out of this screen?
Yeah, now moving. Yeah.
Now is it moving?
Yeah.
You can see what happens when the IPD is incorrect?
Yeah, exactly.
Okay.
So not from the beginning is not moving. I just noted, not noted. Doctor one called. Dr. Pavani called me. Sorry.
It's okay. Should I start once again? Okay. When the IPD is not aligned with the optical center of the lenses, the patient's visual axis will not pass through the optical axis of the ophthalmic lenses, which will induce prismatic effect. The amount of induced prism depends upon the power of the spectacle lenses and the decentration or displacement of the optical center from the IPD.
Just a second.
Hello? Yeah.
Someone is asking from the beginning, please. Can you
From the beginning. All right.
slides just?
Yeah, I can go back, no problem.
Yeah.
Okay, we start from here. Okay. The distance between the center of two pupils is anatomical IPD, which is measured in the millimeter. Now, it can also be measured from the one external limbus to the another internal limbus of other eye. Both measurements will be the same. There are two types of IPDs which we need to take. They serve two different purposes. One is distance PD, another is near PD. Distance PD is measured when the patient is looking at a far distance, and the near PD is measured when the patient is looking at a 40 centimeter distance. Distance PD is usually measured monocularly, and near PD is usually measured binocularly. In this picture, you can see a distance between the green line below the zero to the center of the nose, demonstrated by the dotted green line along the 30 millimeter number. That's the monocular distance PD for the right eye. And the distance between the right pupil center and the left pupil center, as denoted by the yellow arrow, is the monocular PD. Now, the reason why we need a monocular distance PD for distance is to ensure that the patient's line of sight is equally centered for the better performance of the better visual performance through the optical lenses. The objective behind taking the IPD is to make sure that the IPD is aligned with the optical center of the lenses while dispensing. In order to ensure this, we need a distance PD for distance correction or single vision lenses for distance vision. We need a near PD for single vision reading lenses, near lenses, and we need a distance and near PD both for bifocal or progressive lenses. When the PD is not aligned with the optical center, it induces prismatic effect. And the amount of prismatic effect depends upon the power and the decentration of the optical center or deviation of the optical center from the IPD. ज़्यादा पावर होगा तो ज़्यादा prismatic effect induce होगा, कम पावर होगा तो कम prismatic effect induce होगा. और यदि displacement ज़्यादा है, मतलब incorrect PD ज़्यादा हो गई तो ज़्यादा prismatic effect होगा, और यदि कम है तो कम prismatic effect होगा. Now here you can see in the picture on the right hand side, the optical center is shifted towards the nose in plus power. Now when the optical center of the lens is shifted towards the nose in the plus power, it creates a basin effect. Now basin effect relaxes the eye. Basin effect relaxes the eye, so there is no problem while reading. But the patient might see double vision in distance viewing zone. Now you can also see when the optical center is shifted towards the temporal side in the plus lenses. Here you can see on the right picture on the top, where the optical center has been, base of the lens is shifted towards the temporal side, it creates a base out effect. Now when the lens creates a base out effect, it will pull the ocular muscles, and the patient will have a eye strains, muscle fatigue. He will complain of tiredness, fatigue, asthenopia, a lot of things, a lot of difficulties he will complain. Now similarly, in minus power, you can see base out effect when the base is shifted towards the nose, and you can see the base in effect when the base of the lens is shifted towards the temporal side. Now, when there is an incongruency between the optical center and the IPD of the patient, usually the patient will complain of asthenopia, dizziness, nausea, double vision. Usually patients don't complain of visual disturbances. Please remember, because of incorrect PD, patient usually don't complain of poor vision. They may complain of poor binocular vision in extreme cases. They may also complain of poor stereoscopes in extreme cases, but they will not complain of poor vision. 4 types of complaints are quite common: asthenopia, dizziness, nausea, and double vision. Now, there are 3 methods of taking the interpupillary, measuring the interpupillary distance. You can use either ruler, a plain simple ruler, which we call optician ruler, or you can use a specially devised tool instrument, which is known as pupillometer. And if you don't have any instrument, not even the scale, you can measure the IPD using a simple torchlight. You'll see all these 3 measurements. Now measuring the monocular distance PD using the optician ruler. Step 1 is the first and the most important step is you, the dispensing optician, and your patient. They should be at a distance of nearly approximately 40 centimeters, and their eyes should be at the same level. Step 2, place the ruler across the subject's or patient's nose such that it rests on the most recessed part of the nose with the measuring edge tilted back. हाथ में हम लोग right hand with, if you are a right hander, hold the scale in the right hand and place your fingers on the temporal bone of the patient. Hold the ruler slightly tilted down on as shown in the picture. Step 3, cover the patient's left eye and ask him to look at your left eye. Now, once you cover the patient's left eye, you bisect the right eye of the patient and measure the distance up to center of the nose, as shown in the picture. You can see here we are bisecting the center of the pupil, and then we are observing on the center of the nose where the scale in the optician ruler, at which number it is falling. So this distance is the distance between optical pupil and is known as the monocular distance PD for the right eye. Step 4, now cover the patient's right eye and ask him to look at your right eye. Observe the patient where the left eye has been bisected and just measure the distance. As you can see here, we are measuring the distance from the center of the nose to the center of the left pupil of the patient. This is the monocular distance PD for the left eye. You can also measure the PD using the Essilor's scale. This kind of scale has been designed by the Essilor. Here you can measure the monocular distance PD in one step. First, put the scale like this as shown in the picture. Bisect the right eye, cover the left eye, measure the distance between the center of the pupil of right eye to the center of the nose, and then uncover the right eye and cover the uncover the left eye and cover the right eye, and then measure the distance from the center of the nose to the center of the pupil in the left eye. This is monocular distance PD. Now measuring near PD. Measuring near PD is quite simple. Just ask the patient to look at the other center of your nose. Ask the patient to keep the both eyes open and fixate at your nose. Bisect the right eye and observe the point where the left eye is been bisected on the scale. The result will be near PD. Using pupillometer also you can take the IPD measurement. This is very simple. The machine works by its own. The only thing is that you need to know the applications and uses of the different parts of this machine. As you can see in this picture, the A is a focusing distance selector. Here you can select distance for distance vision and distance for the near vision also. Distance for the distance vision is shown by the symbol infinity, and distance for the near vision is given by the 40 centimeters. The area which is denoted by B shows the distance selected, where the patient is actually focusing inside the machine, and the points, the structure shown by C, the letter C, is the knobs which you need to move and align with the pupil reflex. Please remember, here you are not bisecting the center of the eye pupil. Here you are aligning the black line seen inside the machine, inside the tool, with the pupillary reflex. So this machine works on pupillary reflex measurement. Both distance and near PD can be measured together, as distance and near PD is given here monocularly, and the cumulative distance PD is given here. This is the posture that you need to maintain. You and your patient has to be on the same line. Now, there is always a difference of measurement between what you measure using the scale and what you measure using the pupillometer. This is because our pupil is naturally displaced 0.3 millimeter nasally. So pupillometer and optician ruler measurements will always vary approximately by 0.5 millimeter. Measurement using the ruler will yield greater values than the measurements as found by using pupillometer. Measuring the IPD using torchlight. This is a very simple. If you don't have any instrument, you can measure the IPD using the simple torchlight. Ask the patient to sit on a chair, ask him to look straight, close the left eye first, just shine the torch on the patient eyes, observe the pupil reflex, and put a dot mark right against the pupil reflex. And the similar measurement, then you have to carry out the same process for the left eye, and then you can remove the spectacle frame and measure the distance between the two dots, and that is the PD for distance. You can measure right eye PD separately. You can also measure left eye PD separately. Distance from the right upper lens to the center of the frame gives you the right PD, and distance from the center of the brace to the left center of the left center gives you the monocular PD for the left eye. After measuring the optical IPD of the patient, you must align this IPD with the optical center while dispensing the glasses. Now, the point at which the optical center of the lens should be located in the absence of any prescribed prism is called the centration point. In order for the optimum performance of the lenses, it is necessary for the optical axis of the lens to pass through the eye's center of rotation, and this is achieved by lowering the optical center of the lens to compensate for the tilted spectacle frame. Please remember, our spectacle frames are always tilted on the face. They always have a positive pentascopic angle. This is to ensure a parallel relationship between the eye and the spectacle lenses. Now, when this kind of fitting has been done on the in the spectacle frame on the user's face, you must compensate for the distance, and this is done by lowering the optical center. The dispensing rule is that optical center of the lens should be lowered by 0.5 millimeter for every 1 degree of pentascopic angle. Now, go back to the lecture of the spectacle frames, where we saw that when the spectacle dress wear spectacle frames comes out of the factory, they usually have 6 to 8 degree of pentascopic angle, which means for every millimeter you need to put the optical center below by 0.5 millimeter, which means 4 to 5 millimeter below you must fit the optical center in a spectacle dispensing. Now, this is usually done as a standard procedure. No additional instruction is given to the lab. Lab people knows this as a standard procedure. Now, the other advantage of doing this is that the edge thickness in case of minus lenses at the top and bottom is almost similar. They match, and the cosmetic look of the spectacle is enhanced. This also ensures that there is no further need for vertical decentrations of the optical center is needed for near vision, as it is between the distance vision and the near vision. The important factor to remember here is that if there is a incongruency of IPD in horizontal measurement, we have a bit of leeway. The patient may not complain, may not also talk about any asthenopia, may not talk about double vision. We have a bit of leeway. But if IPD is incorrectly dispensed vertically, even a 1 degree, 1 prism diopter can produce a double vision. So the vertical placement of IPD is very, very important. So this is all about IPD measurement. Now we are going to the segment height measurement. Now in a multifocal lenses, optical correction for distance vision is usually provided at the top of the lenses, and the optical correction for the near vision is provided at the bottom of the lenses. This is simply because distance objects are generally higher in the field of view, and the near objects are lower in the field of view, and an individual, all patients, assumes a downward gaze angle of approximately 20 to 30 degree to read at a near viewing distance. Now, success of multifocal dispensing depends a lot on the correct placement of the near segment, especially in case of segmented bifocal lenses. Two measurements are very important, very critical for the placement of near segment in case of bifocal lenses. Same like PD, vertical positioning of the near segment and the horizontal positioning of the near segment. We'll talk about the horizontal positioning first, because this is done automatically. We don't take any extra measurement for that. Horizontal positioning of the segment is specified as a segment inset, and segment inset is specified as a difference between the patient's distance PD and near PD. If you remember, we just talked about that there is a difference between the patient's near PD and the distance PD, and the difference is usually between the varies between the range of 4 to 5 millimeter. Now, in the normal range of PD, that is at reading distance is 40 centimeter, the gap of 4 millimeter or less. Segment inset, therefore, is usually specified as 2 millimeter for each lens. There are two reasons for insetting the segment bifocal. Number one, to ensure that the patient's line of sight passes through the segment at its optical center. And number two, to ensure that the reading fields of the two segments coincides with one another. What is segment height? Now, segment height, also known as sag height or SH in dispensing parlance, is the vertical measurement in millimeters from the bottom of the lens in your spectacle frame to the top line or top of the segmented bifocal, as you can see. You can see in this picture, this is the distance from this point to the top portion of this segment. It determines the vertical position of the segment in the spectacle. Now, please try and understand this measurement is taken from the deepest portion of the frame. Now this, although the segment insetting is at this position, it is displaced towards nasal, towards nose, and distance from here to the bottom of the rim is little shorter than this, but the measurement is always taken from the deepest part of the frame. Some people measure segment height, whereas some people measure segment drop. Both gives you the similar measurement. The difference is that segment drop is the distance measured in millimeter from datum line to the top margin of the near segment of the bifocal lenses. If you look at this figure, I told you the line passing through the center of the vertical length of the, this is the vertical length of the spectacle lens, and the line passing through the center of this vertical aperture of the lens is known as the datum line. Now, distance between this datum line to the top of the segment top is known as center segment drop. Now, fitting of segment height, correct segment height is very important for successful dispensing. Now, if the segment is incorrectly fitted, say for example, if it is fitted up, as you can see in the extreme right picture, the patient will have to bend his neck down to look at the far distance, and he will try and peep through the top portion of the lenses. Now, if the patient, and you compare the same thing with the picture given on the extreme left, at the middle of the picture, mid picture. Here the segment is fitted lower than the standard height. The patient will have to raise his cheek to read at the for reading. So he will complain of neck problem, neck pain. Now this is the, when the segment height is fitted correctly, the patient will also assume the natural posture while reading. He will not complain of obstruction of any line in distance vision, nor he will complain of neck ache. Now, while measuring the vertical position of the near segment, you must make sure that the top edge of the segment or the line of near segment should in any way never interfere with the distance vision in straight ahead gaze. When the patient is looking at a far distance, he should not feel the obstruction of the segment top. In order to measure the vertical position of the near segment, lower lead margin is usually taken as a reference point for the purpose of measuring the segment height. Some scholars advocate lower limbus as a reference point for the purpose. However, the difference is mostly academic, since they are usually approximately at the same position. However, if the lower lead is unusually lower than the lower limbus margin is usually taken as a reference for measuring the vertical position of the near segment. जो हमारा लोअर लीड मार्जिन है, उसके रेफरेंस से हम सेगमेंट हाइट को मेजर करते हैं. सम स्कॉलर्स जो है वो बोलते हैं कि हमें लोअर लिम्बस मार्जिन के रेफरेंस से मेजर करना चाहिए. यूजुअली मोस्ट केसेस में लोअर लिम्बस एंड लोअर लीड में डिस्टेंस बहुत ज्यादा नहीं होता, लेकिन यदि किसी केस में आपको दिख रहा है कि गैप बहुत है, तो ideally we should take the lower limbus as a reference point. In order to measure the segment height, you should follow a step-by-step process so that you don't make any mistake. At the first, you must adjust the spectacle frame for three important elements of the frame fitting, which is pentoscopic tilt, frontal bow, and the nose pad. Now, once you adjust these three things, the frame will be stable on the patient's face. Now, When the frame is adjusted, ask the patient to stand or sit at your eye level. Put the adjusted frame on the patient's face and ask him to look straight ahead at your eyes. It is suggested that the position of the segment top should be measured when the head is held straight ahead and the viewing gaze of the patient is in a primary gaze position. Place dots at the same height as the lower edge of the patient's right lower eyelid. Similarly, without moving his head, also mark in front of the patient's left eye. First, you mark on the right lenses, then you do the same measurements on the left lenses also. Then remove the frame, put the frame face down on a piece of paper and join the dots coinciding with a straight line. Then you put on the spectacle frame on the patient's eye and check whether the line drawn on the demo lenses is at the height of lower lid or not. Now this is how you can measure the height of the segment. Now after marking the height or after measuring the height, you can verify whether your height is correctly measured or not. This is a simple test. What you can do, you can cover the lower half of the spectacle frame with some card, and you can ask the patient to look at a distance of approximately 10 to 15 foot. And if you can see the floor without the obstruction of the top edge of the card, the height is correctly measured. Same you can do for near vision also. You can cover the upper half of the lens aperture and ask the patient to look while reading, while looking at the reading object. If the distance, if the top, I mean the bottom of the card is not obstructing while viewing at the reading object, the height marking is correct. Once the line has been marked, you can measure the distance between the top of the line and the extreme bottom of the lower ring is gives you the distance in millimeter. Now, for different types of segment, you need to consider some important criteria. For example, if you are dispensing an executive bifocal as shown in the extreme top left picture, where we have a thicker line, demarcation line, in an ideal scenario, it should be fitted half or 1 millimeter lower than the lower limbus also, because this line of division is very thick. Now, if it is a D bifocal, it can be right at the lower limbus, lower eyelid height. And if it is a round shape bifocal, it can also be at the lower limbus height. But if it is an invisible segmented bifocal lenses, like you can see here at the left picture at the bottom, here the segment is not visible. What happens? The edge of the segment is obliterated, and the process of obliteration creates some sort of error at the segment margin. So in an ideal situation, it should be fitted at least 2 to 3 millimeters above the lower lid, so that the aberrations created because of this obliteration process does not affect the vision while reading. This is very important for invisible segmented bifocal lenses. Trifocals are fitted. Trifocals have got 3 viewing zones. As you can see here in this picture, this is the lower segment used for near vision, and this is the middle segment used for the intermediate distance. And from this area, you can view the distance vision. Now, the top edge of the segment should be always fitted with reference to the lower edge of the pupil for trifocal lenses. Now, these are about the fitting aspect measurements for the segmented bifocal and multifocal lenses. For progressive lenses, there is no segment, there is no demarcation line. All progressive lenses comes with some markings like this. There are some laser markings which are permanent, and there are some ink markings which are temporary. We have a fitting cross also, which is a temporary ink marking. You need to align this fitting cross with the monopolar distance PD of the patient. Segment height can be sorry, also measured using a die test tool introduced by the SCO. This is a scale where you can it measures the PD and the segment height in one go. You can see it's a very simple. You just need to align this line with the center of the pupil, and it gives you the height as well as the IPD. Now, while measuring the patient's segment height for a patient, some important things needs to be considered. Past habit is one of the important criteria that you must consider. If the patient is using abnormally up height, then ideally in an ideal scenario you should maintain with that, because if you make it and correct it and fit it at the normal height, standard height, probably the patient might complain. So past habit is very, very important to maintain. So while measuring, you must make sure that you check the segment height of the existing spectacle. Patient's physical height is also very important. Tall people usually have a habit of keeping the neck little bent. So for them, the height should be little up, and the short people usually keep their neck little up. So for them, the segment height should be a little down. Otherwise, there will be an obstruction in the distance vision. And besides these two, occupational need of the patient should also be considered. If the spectacle is made for primary for the reading use, you may consider to provide a segment height little upper so that reading is more comfortable. For customized lenses, you need to take some measurements which you cannot take manually by any manual tools. You need to have a digital measuring device in your optical store, in your dispensary. And these devices are very expensive. They cost around more than 10 lakhs, and they can measure pentoscopic tilt, they can measure faceform wrap, they can measure vertex distance, they can measure dominant eye, they can also measure your facial posture, they can also measure head and eye ratio, they can also measure your dominant eye. And these measurements last day we discussed are very important to dispense customized lenses. If you do not take these measurements, you cannot dispense customized lenses. So this machine is used, which is very easy. It's a completely software driven. You just need to ask the patient to look at the screen and go on the process as displayed in the screen. Dispensing challenges. Each case poses different challenges. For example, myopia, there are different challenges. While dispensing spectacle for myopes, you have a challenge of minimizing the thickness, lens thickness. Myopes are more conscious about the edge thickness of the lenses. So you can think about reducing the edge thickness. There are different criteria for reducing the edge thickness. You start by dispensing the higher index, number 1, and then you start think of giving in the smaller size, number 2. Then you also try and dispense with the symmetrical shape of the frame, number 3. Combining all these 3 elements, you can really minimize the lens thickness. Kindly please remember, alone index or alone the size of the frame or the shape of the frame cannot effectively reduce the edge thickness of the lenses. You have to combine all 3 factors together. Then you also have a challenge of reducing the lens weight, especially in case of high power lens, high minus cases, because the lenses are very thick. And if you dispense the abnormally high index lenses, because specific gravity of the lenses are more, so the weight of the material increases. So there are lots of ifs and buts for selecting the right, for minimizing the lens weight. The most ideal is dispense with a smaller frame. If the lens, that reduces the lens mass, and when the lens mass is less, so the weight is automatically reduced. However, there are two materials: mineral material, which are made of glasses, and organic material, which are made of plastics. Plastics are always lighter than the glasses. In fact, glasses are becoming obsolete day by day. Then, third more important challenge that you face while dispensing the glasses spectacle to a myope is the minimizing the reflections. Last day we understand that if you try and dispense the aspheric lenses, that is the flatter lenses, so flatness of the lens increases the lens reflection, and lens reflection is not good for the eyes. So always dispense aspheric lenses with anti-reflection coating. This is very important. And then there are reflections inside the lenses also because of total internal reflection. We discussed about it in our first session, which can also be minimized using the anti-reflection coating. Then lens aberrations are very effective in case of minus, because especially in high lens prescription, which can be also minimized by giving the smaller size of the frame. Improving the cosmetic look can be achieved in two ways. Number one, by reducing the lens thickness. So high index opens the door for that. Then you can also make the lenses flatter and thinner, which can be done by using the aspheric lens design. The most important challenge that you face with a thicker lens prescription is fitting the metal frame on the patient's eyes. They really poses a lot of problem. Thicker minus lens poses a lot of problem in fitting the spectacle frame on the nose, because you cannot adjust the nose pad. The edge thickness of the lenses obstructs the fitting or modification of the nose pad. In case of plus power, you have a different set of challenges. Here the biggest challenge is you need to reduce the thickness of the center thickness of the lenses, and also you also need to minimize the effect of magnification, because plus chapter lenses magnifies the eyes and cosmetically it does not look nice. So there are two ways of doing it: dispense the lenses with the flatter aspheric surfaces and also with the anti-reflection lenses. Flatness of the lens will apparently reduce the magnification of the eyes, and coating with the ARC treatment will ensure the natural look of the eyes. Then again, weight of the lens is important. Organic lenses are lighter in weight, mineral lenses are heavier in weight. In improving the cosmetic appeal is not very critical in case of hypermetropic cases, because edge of the lenses are very thin. The only consideration is if you can reduce the magnification of the eyes because of the curvature of the lenses, you can ensure the good look of the spectacle also. We have a completely different set of challenges for the presbyopic population. The biggest challenge is which multifocal type, whether to dispense with the moon-shaped bifocal, or with D-shaped bifocal, or executive bifocal, or a progressive lenses. This is a very challenging factor. Now, in order to combat with this challenge, you need to understand the optics of round-shaped bifocal. You also need to understand the optics of D bifocal and executive bifocal, and you also need to understand the everything about the progressive lenses. So this is really a very challenging factor which you must consider while dispensing the progressive any multifocal lenses for presbyopic population. Now, dispensing multifocal lenses itself poses the problem, because patient with bifocal lenses, he can only look at two distances, one at a distance vision, another at a near vision. And with the trifocal lenses, he can look at three distances, distance, near and intermediate distances. However, with the progressive lenses, he can look at a several near vision distances from 40 centimeters to 60, 65, 70 centimeters also, because the power from distance to near progresses gradually, which gives you a corridor length to look at a distance different near viewing distances. Besides that, adaptation is also an issue. All presbyopic patient complaints of adaptation, especially when they have been prescribed with the bifocal lenses for the first time. Each type of bifocal have got their own issues. You need to understand the optics, then only you'll be able to handle them. However, a mature presbyope usually don't poses problem while when he changes. Yes, they will also create problems when you will switch them from one bifocal design to another bifocal design. So these are the challenges of presbyopic population. Before dispensing the glasses or handing over the spectacle to the patient, if you ensure some checks are being done, then probably you can minimize a lot of error or a lot of adaptation issues. There are some important checks and rechecks that you must do before handing over the spectacle to the user. Check the lens power using the lensometer. Check the prism using the lensometer. Check the PD. You can check it either with the help of lensometer, or you can also check manually. Check that right and left tints are both similar. Check there is no scratches or apparent defects in the lenses. Check that the frame, there is no defect in the frame also. Adjust the spectacle frame on the wearer face. Please make sure that you check the past fitting of the spectacle frame before making any modification in the frame fitting of the new spectacle frame. Past habit is very, very important. If there is a lot of changes compared to the previous fitting, then again the patient might create problems. Check the segment height, and in case of progressive lenses, fitting cross height. Advise care and maintenance, advise handling. In case there is an adaptation issues, advise accordingly. See, there are some troubles or complaints of patient which can be overcome after using for some days, and there are some issues which can never be overcome. The patient might continue facing them even after the use of 2 weeks or 3 weeks. And if the glasses are not suiting even after the use of 2 to 3 weeks, then there are some issues. The issues might be either with the lens prescription, or issues might be with the dispensing of the glass spectacle. So both things has to be carefully checked. Prescription has to be checked, dispensing has to be checked, fitting of the spectacle frame has to be checked. That's all about dispensing measurements. I am through with my lectures. So in case anyone wants to ask.
Hello.
If in case anyone want to ask any question.
Hello. Hello.
Yeah.
हेलो सर.
Yeah.
सर प्रोग्रेसिव के बारे में थोड़ा हिंदी में बता सकते हो सर?
हाँ जी, प्रोग्रेसिव के बारे में हम लोग नेक्स्ट सेशन में डिस्कस करेंगे.
सर थोड़ा हिंदी में बता सकते हो?
डिस्कस करेंगे, कोई दिक्कत नहीं. नेक्स्ट सेशन में हम लोग डिस्कस करेंगे.
ओके सर.
हमारा प्रोग्रेसिव अभी बाकी है.
ओके, तो हिंदी में बता सकते हो ना?
हाँ जी, पूरा हिंदी में बोल देंगे, कोई दिक्कत नहीं है हमें.
ओके, आईपीडी के बारे में भी हिंदी में.
अच्छा, आईपीडी मैं फिर से बोल देता हूँ. राइट आई के ऑप्टिकल सेंटर, सेंटर ऑफ द प्यूपिल से लेफ्ट आई के सेंटर ऑफ द प्यूपिल का जो डिस्टेंस होता है उसको आईपीडी बोलते हैं. ठीक है.
ओके.
डिस्टेंस का आईपीडी अलग से लिया जाता है, नियर का आईपीडी अलग से लिया जाता है. डिस्टेंस का आईपीडी मोनोकुलरली लिया जाता है, मतलब राइट आई का अलग से लिया जाता है, लेफ्ट आई का अलग से लिया जाता है, जबकि नियर का आईपीडी हम एक साथ लेते हैं.
ओके.
और कुछ पूछना है?
हेलो.
हाँ जी.
Sir, myself, Anup Shah. I think this was one of the most important lectures जहाँ पर आपने बेसिक के बारे में सब कुछ बहुत अच्छे से बताया है, लेकिन
Thank you.
सीखने के लिए इतनी सारी चीजें एक साथ आ गई कि it was a little difficult for us to grasp at one go. So I would request either you take this lecture again on say Sunday or something where it is a non-working day, or
Okay.
at least provide us with the link so that we can go through it at least once at our leisure, because this is, I think, very, very important basic, so that everybody should be thorough with this. So it is my request.
What I will do, I will create a Word document as I have been doing it, और मैं
हाँ।
आपको आज रात को 11 बजे या कल सुबह तक भेज दूंगा WhatsApp ग्रुप में.
Okay, sir. Okay. Thank you very much, sir. Thank you. It
My
was
pleasure,
really
sir.
very nice, sir.
My pleasure, sir. My
Thanks.
pleasure. Anyone else want to ask anything? Please feel free to ask. Let me apologize for all these technological glitches, because I am not very technologically savvy guy.
हेलो.
Yeah.
हाँ सर, एक क्वेश्चन था कि अगले सेशन में क्या क्या डिस्कस होने वाला है, मतलब
हमारा
progressive और
अगले
कौन सा
सेशन
topic
के
कुछ-
लिए एक्चुअली 3 लेक्चर अभी पेंडिंग है.
Okay.
अब तीनों लेक्चर यदि उस दिन हो गया तो ठीक है, चेष्टा करेंगे हम लोग तीनों लेक्चर कंप्लीट करने का. एक प्रोग्रेसिव है विच इज वेरी इंपॉर्टेंट, और प्रोग्रेसिव में हम लोग 3 चीज डिस्कस करना जरूरी है टू अंडरस्टैंड द प्रोग्रेसिव. एक तो प्रोग्रेसिव का एनाटॉमी, दूसरा प्रोग्रेसिव को कैसे डिस्पेंस किया जाता है, ये 2 चीज को बहुत जरूरी है डिस्पेंस करना, और डिस्पेंस करने के बाद आप प्रोग्रेसिव लेंस को कैसे चेक करेंगे. ये 3 चीज प्रोग्रेसिव के बारे में डिस्कस करना बहुत जरूरी है फॉर सक्सेसफुल डिस्पेंसिंग. बाकी चीजें हम नहीं डिस्कस करेंगे, अदरवाइज प्रोग्रेसिव इटसेल्फ बहुत बड़ा चैप्टर है.
हाँ, और जो आंखों का लेजर ऑपरेशन के बारे में भी कुछ सेशन है या फिर नहीं है?
नहीं जी, दैट इज नॉट द कोर्स मटेरियल ना, ये तो डिस्पेंसिंग का कोर्स है.
ओके ओके, नहीं पूछा.
अच्छा, इसके अलावा हम चेष्टा करेंगे थोड़ा बहुत हम ऑक्यूपेशनल डिस्पेंसिंग के बारे में बात करेंगे शॉर्ट में, और थोड़ा बहुत शॉर्ट में हम ट्रबल शूटिंग के बारे में बात करेंगे. दैट्स इट.
ये आज का सेशन सर ऐसे पूरा ज्यादातर से हिंदी में, अगर ऐसे बाकी जिनको हिंदी जिनको समझ जाना अच्छी तरह से आता है तो ऐसे
कोई
कौन से
दिक्कत
भी
नहीं, यदि आप
में-
पूछिए क्या पूछना, मैं अभी दोबारा से हिंदी में बोल देता हूँ.
नहीं वैसा नहीं, वो कैसा रहता है, लिंक रहता है जो सुनने में लग जाता है ना, तो जैसे
हाँ.
आप हिंदी में बताएंगे तो वो ऑटोमेटिकली समझ में आता है ज्यादा अच्छी तरीके से. इंग्लिश में
अच्छा.
कैसे समझता है, पर वो समझना और सुनना थोड़ा अलग चीजें रहता है, तो हिंदी में
कोई
कैसे ज्यादा.
दिक्कत नहीं है, कोई दिक्कत नहीं, मैं हिंदी में बोल सकता हूँ, मेरे को कोई दिक्कत नहीं है.
हाँ वही कि नहीं, ये अभी जिनको इंग्लिश ज्यादातर से अभी सब पार्टिसिपेंट्स है, तो ऐसा कोई कि समझो 10-12 कोई पार्टिसिपेंट रहेंगे जिनको हिंदी में ही अटेंड करना रहेगा. ये मतलब आज का सेक्शन ज्यादातर से आज का सेशन.
दिक्कत नहीं, यदि आप चाहते हैं तो आप लोग आइडेंटिफाई कर लीजिए, एक दिन मैं खाली आप लोगों के लिए हिंदी में कर लूंगा.
चलेगा ना एक दिन प्लीज सर, क्योंकि मतलब वो एक दिन
कोई
में
दिक्कत
लगभग
नहीं है.
सब.
आप डॉक्टर सेंथिल के साथ में या मिस्टर हरी के साथ में कोऑर्डिनेट कर लीजिए, और वो यदि मेरे को बोल देंगे कि इस दिन हिंदी में करना है, तो मैं उस दिन एक भी वर्ड इंग्लिश के नहीं यूज करूंगा.
चलेगा, कोई
आई
प्रॉब्लम.
प्रॉमिस.
चलेगा हम हरी सर से बात करके एक दिन ऐसे
आप कर लीजिए बात और अरेंज करवा लीजिए, मैं उस दिन सिर्फ हिंदी में बोलूंगा.
चलेगा कोई प्रॉब्लम.
हाँ जी सर, और बताइए.
ओके, थैंक यू.
हाँ जी.
Any other questions, please, participants? You can unmute and ask your questions, please.
Sir, if you have the recordings, please share the recordings, at least for once we can use it as a revision, because in one go it is difficult to understand, and not only that, it's a working time bit at 6 o'clock. So,
Yeah, sure. So we are all the recording we are sharing in the group. So last 2 sessions already shared in the group. So this will also share by Monday. Okay.
Sir, unfortunately, I have not received the previous recordings. I don't know, is there any other group? If at all, please add me in that group and please
Yeah.
share the previous 2 recordings. I do not have the recordings with me.
Yeah, complete. Now itself, I will share you the 2 recordings. Okay.
Okay, sir. Thank you. Thank you.
Thank you. Thank you.
So Mr. Hari, so we can disconnect for today?
Yeah, today we will say end the session.
Yeah, we are already very late today.
Yeah, thank you so much for all the participants. Thank you so much for your kind response and cooperations. So you please give me your feedbacks so we can improve our this thing depends upon your feedbacks. Please give me your feedbacks.
Yeah, feedbacks are very important because that helps us to improve. So please do provide feedbacks.
Okay, sir.
Thank you.
Thank you so much. Good night.
Good night.